grade 8 learners, welcome to Bamboo Telescuela. This is your school on air in mathematics. I am so glad to have you today in our discussion through our radio and telecasting mode of learning. I am John Paul P. Manabat from the school's division of Kawayan City. You can call me Teacher Paul, and I'll be your teacher for today. Before we begin, make sure you are in a comfortable place and can clearly hear me in your radio or see me in your screen. Have you taken your snacks? It is very important that your stomach is full and your body is in good condition so your mind is alert and ready to listen to understand the lesson we are going to discuss today. In this session, we will focus on factoring perfect square trinomial, factoring general trinomial, factoring by grouping, and solving problems involving factoring. At the end of the lesson, we are expecting you to factor polynomials. Let's begin with the first type of factoring, factoring perfect square trinomial. This kind of product is the result of squaring a binomial. In symbols, we can have them in two forms. The first one is a plus b squared is equal to a squared plus 2ab plus b squared, or a minus b squared is equal to a squared minus 2ab plus b squared. But how do we know that a trinomial is a perfect square trinomial? For us to say that a trinomial is a perfect square, it must satisfy two simple conditions. Initially, first term and last term are perfect squares, and the middle term must be twice the product of a and b. So the middle term must be a positive twice the product of a and b, or negative twice the product of a and b. Let's have this example. Is 9x squared plus 30x plus 25 a perfect square trinomial? Let's have a closer look. First, two of them must be positive perfect squares. 9x squared is the square of 3x, and 25 is the square of 5. Next, the middle term must be positive twice the product of the x and y, or negative twice the product of x and y. Multiplying 3x and 5 will give a product of 15x. Now, twice 15x is 30x, which is the middle term of the polynomial. Indeed, 9x squared plus 30x plus 25 is a perfect square trinomial. Now let's check the following polynomials and see which of them is or are perfect square or perfect squares. Let's see how the conditions earlier worked with these polynomials. First, let's have 9x squared minus 30xy plus 4y squared. The terms 9x squared and 4y squared are both perfect squares of 3x and 2y respectively. However, twice the product of 3x and 2y is not negative 30xy, but 12xy. Next is x squared plus 7x plus 6. The term x squared is the square of x, but 6 is not a square. From here, we can say that x squared plus 7x plus 6 is not a perfect square trinomial. Lastly, 4x squared plus 12x plus 9. The terms 4x squared and 9 are both perfect squares of 2x and 3, respectively. At the same time, twice the product of 2x and 3 is 12x. The polynomial satisfied the conditions, therefore, 4x squared plus 12x plus 9 is a perfect square trinomial. Now, we're ready to factor perfect square trinomials. To factor a perfect square trinomial, you can use the following rules. First is, quantity a plus b squared is equal to a squared plus 2ab plus b squared, or quantity a minus b squared is equal to a squared minus 2ab plus b squared. The following steps can be used to find the factors of a perfect square trinomial. Step 1. Determine whether the first term and the last term are perfect squares. Step 2. Look at the middle term. Check whether it is twice the product of the square root of the first term and last term. If conditions 1 and 2 were satisfied, then the expression is a perfect square trinomial. And step 4, factor completely the given trinomial following the pattern a squared plus 2ab plus b squared is equal to quantity a plus b squared, or quantity a plus b multiplied to quantity a plus b. Similarly, a squared minus 2ab plus b squared is equal to quantity a minus b squared, or quantity a minus b multiplied to quantity a minus b. Let's have this example. Factor a squared plus 6a plus 9. Step 1. Determine whether the first term and the last term are perfect squares. A squared and 9 are perfect squares of a and 3 respectively. Step 2. Determine whether the middle term is twice the product of the square root of the first term and the last term. Twice the product of a and 3 is 6a. Step 3. Since the conditions are satisfied, then a squared plus 6a plus 9 is a perfect square trinomial. And step 4. Form a binomial using the square roots found in step 1, taking the sign of the middle term of the given trinomial. Using the terms a and 3, form a binomial and use the sign of the middle term plus 6a as an operator to separate the two terms. Therefore, we have a plus 3. Square the binomial. Finally, we have quantity a plus 3 squared. Let us factor m squared plus 12m plus 36. Step 1. Determine whether the first term and the last term are perfect squares. M squared and 36 are perfect squares of m and 6 respectively. Determine whether the middle term is twice the product of the square root of the first term and the last term. Twice the product of m and 6 is 12m. Since the conditions are satisfied, then m squared plus 12m plus 36 is a perfect square trinomial. Form a binomial using the square roots found in step 1, taking the sign of the middle term of the given trinomial. Using the terms m and 6, form a binomial and use the sign of the middle term plus 12m as an operator to separate the two terms. Therefore, we have m plus 6 is squared the binomial. Finally, we have quantity m plus 6 is squared. Now, we are moving on with another type of factoring, factoring general trinomials. Factoring general trinomial consists of two forms. One is a quadratic trinomial where a is equal to 1, that is x squared plus bx plus c. And the other one, which is a quadratic trinomial where a is not equal to 1, that is ax squared plus bx plus c. Let us find the product of the binomials x plus 2 and x plus 3 using the FOIL method. The resulting product for the first terms is x squared, 5x for the sum of products of outer and inner terms, and 6 for the product of the last terms, giving us x squared plus 5x plus 6. The product x squared plus 5x plus 6 is of the form x squared plus bx plus c, where the coefficient of the squared variable is 1. Now, if the constant c is a perfect square, then proceed to factoring using factoring perfect square trinomial. If not, factor the product as two different binomials. The following steps would be beneficial in factoring quadratic trinomial of the form x squared plus bx plus c. Step 1. Find two factors with the product equal to the last term c of the trinomial and the sum equal to the middle term b of the trinomial. Step 2. Write the factored form of the trinomial following the pattern: quantity x plus or minus the first factor multiplied to quantity x plus or x minus the second factor. The sign in the last term of the binomial factors can be minus signs depending on the signs of b and c. Now let's have the first example: factor x squared plus 7x plus 10. Step 1. Find two factors with a product equal to the last term c of the trinomial and the sum equal to the middle term b of the trinomial. Here, you are going to find two factors whose product is 10 or the last term, and whose sum is 7 or the middle term. Refer to the illustration. Since the middle term b is 7, the correct numbers to be used are 2 and 5 because 2 and 5 will give us a product 10 and the sum 7. Step 2. Write the factored form of the trinomial following the pattern. Quantity x plus or minus the first factor multiplied to quantity x plus or minus the second factor. X squared plus 7x plus 10 is equal to quantity x plus 2 multiplied to quantity x plus 5. Now let's have the second example. Factor x squared plus 2x minus 15. Find two factors with the product equal to the last term c of the trinomial and the sum equal to the middle term b of the trinomial. Here, you are going to find two factors whose product is negative 15 or the last term and whose sum is 2 or the middle term. Since the product is negative, the two numbers must have different signs. And since the sum is positive, the bigger number, the number with a greater absolute value, it must be positive. Refer to the table. Since the middle term b is 2 and the correct numbers to be used are negative 3 and 5. Because negative 3 and 5 will give us a product of negative 15 and a sum of 2. Step 2. Write the factored form of the trinomial following the pattern. Quantity x plus or minus the first factor multiplied to quantity x plus or minus the second factor. X squared plus 2x minus 15 is equal to quantity x minus 3 multiplied to quantity x plus 5. Let us discuss the second classification of general trinomial, ax squared plus bx plus c, where a is not equal to 1. Now, consider factoring trinomials which the coefficient of the squared term is other than 1, such as the following: 6x squared minus 5x minus 6 and 3x squared plus 17x plus 10. Trinomials of these forms also have two binomial factors in which you need to consider the ax squared term, the bx term, and the c term in getting the two binomial factors. There are many ways of factoring this type of trinomials. One of those is through trial and error. But there is a notable way of factoring this kind of trinomial, which is called factoring by grouping. The following are the steps in factoring trinomials of the form ax squared plus bx plus c, where a is not equal to 1. Step 1. Multiply the first term and the last term of the trinomial. Ax squared multiplied to c is equal to ac multiplied to x, where ac is the constant. Step 2. Get the possible factors of the product of the first term and the last term of the trinomial in such a way that their sum is equal to the second term of the trinomial. Say, ac multiplied to x squared is equal to quantity nx multiplied to quantity mx, where nx and mx are the factors of acx squared, and nx plus mx is equal to bx, or the second term of the trinomial. Step 3. Replace the middle term bx by the two factors. Ax squared plus bx plus c is equal to ax squared plus nx plus mx plus c. Step 4. Group ax squared plus nx plus mx plus c as follows. Quantity ax squared plus nx plus quantity mx plus c. Step 5. Factor out the greatest common monomial of each group such that you can obtain the same binomial factor. Step 6. Combine the greatest common monomial factor of each group and multiply it to the same binomial factor obtained in step 5. The result serves as the factors of the trinomial. Now let's have an example. Factor 6x squared minus 5x minus 6. Step 1. Multiply the first term and the last term. Quantity 6x squared multiplied to negative 6 is equal to negative 36x squared. Step 2. Get the possible factors of the product of the first term and the last term of the trinomial in such a way that the sum will be equal to the second term of the trinomial. Here, the product is negative 36x squared and the sum is negative 5x, which is the middle term. Since the product is negative, the two numbers must have different signs. And since the sum is also negative, the bigger number or the number with the greater absolute value must be negative. Refer to the table. Observing the table, the combination of 4x and negative 9x are the ones with the sum of negative 5x and the product of negative 36x squared. In step 3, replace the middle term in such a way that ax squared plus bx plus c is equal to ax squared plus nx plus mx plus c, where nx and mx are the factors. Here, the factors are 4x and negative 9x. We have 6x squared minus 5x minus 6 is equal to 6x squared plus 4x minus 9x minus 6. Step 4. Group ax squared plus nx plus mx plus c in this pattern. Quantity ax squared plus nx added to quantity mx plus c, or 6x squared plus 4x minus quantity 9x plus 6. Notice that the operation used in the second group was changed. This will happen if the operation between the two groups is minus or negative. Always do this if you encounter this case. In this case, negative 9x minus 6 becomes 9x plus 6. Step 5. Factor out the greatest common monomial factor of each group such that you can obtain the same binomial factor, giving us quantity 6x squared plus 4x is equal to 2x multiplied to quantity 3x plus 2, and negative quantity 9x plus 6 is equal to negative 3 multiplied to quantity 3x plus 2. 2x and negative 3 are the greatest common factor, and 3x plus 2 and 3x plus 2 are two the same binomial factors. Step 6. Combine the greatest common monomial factor of each group and multiply it to the same binomial factor obtained in step 5. The result serves as the factors of the trinomial. So, 6x squared minus 5x minus 6 is equal to quantity 2x minus 3 multiplied to quantity 3x plus 2. Finally, we are ready with solving problems involving factoring. For us to be guided, we are going to consider some essential steps in solving worded problems. Step 1. Choose a variable to represent what is unknown. Step 2. Translate what you are seeing in words into mathematical expressions, meaning write the equation based on the given information. Step 3. Simplify the expression and solve for the unknown. Let's try this out with an example. The area of a square is numerically equal to 50 times its perimeter. Find the length of a side of the square. Solution. Step 1. Choose a variable to represent what is unknown. Let S be the length of the side of a square. Step 2. Translate what you are seeing in words into mathematical expressions, meaning write the equation based on the given information. Note that area of a square with side S is A is equal to S squared, and its perimeter is P is equal to 4S. Hence, S squared is equal to 50 multiplied to 4S. Step 3. Simplify the expression and solve for the unknown. S squared is equal to 50 multiplied to 4S. This is the equation obtained in step 2. Next, S squared is equal to 200S when simplified. And S squared minus 200S is equal to 0 by placing all polynomials on one side of the equation and set to 0. S multiplied to quantity S minus 200 is equal to 0 by factoring the polynomials. S is equal to 0 or S minus 200 is equal to 0 because of the zero product property. S is equal to 0 or S minus 200 plus 200 is equal to 0 plus 200 using the additive inverse property. And finally, the resulting equations are S is equal to 0 or S is equal to 200. Since the length of a square could not be 0, hence, the length of the side of the square is 200 units. There are many ways to illustrate real-life situations depending on what technique interests you most. You need to develop your understanding about factoring polynomials through accomplishing the activities on your module. I hope you understand our lesson for today. If not, you can text or call your teacher for questions or clarifications, or you can message them through your group chat, Messenger, or Facebook. One lesson has been done for today. Be sure to tune in on our School on Air every day at scheduled time at TWNDFM 88.5 or watch on CND Cable Television or watch on Kawayan City Division Facebook Live. Once again, this is Teacher Paul, your teacher in Mathematics 8. Have a great day and stay safe, everyone.